Everybody, and welcome to Handmade Hero, the game where we code a complete show on stream. Not sure why I decided to say that backwards today. Um, you could really think of them as interchangeable. So today is a special two-stream day. There's a reason for that. It was not an accident. Some people thought the bot malfunctioned. It didn't. It is intentional. So today I want to do something because we have had I don't want to necessarily call it a request, but an opportunity was available to help someone out who is a friend of mine and who was actually a programmer I highly respect and admire, but somebody who doesn't do any 3D programming. That's just not what they do, right? And I will keep their identity private. I don't know if they want to talk about it yet or what's going on, but so we're just going to say it's someone who I respect. And they had asked me recently about, do you know anyone who's available to do the 3D backend for this like sort of pseudo 2D, 3D game? It's like mostly sprite graphics, but there's some stuff I want to do. And I was like, well, what are you trying to make it look like? And they sent me a screenshot that looks a lot like our renderer. It's like blocks with bitmaps on the side of them and then sprites in it. And I was like, well, I don't know any good 3D programmers who are available right now because, as usual, all good 3D programmers are almost always at a job somewhere. They're in very high demand, and they're very hard to find. But I said, if you want, you can try using the Handmade Hero renderer to at least get you going, and maybe, maybe that'll be enough. It probably isn't not to ship a whole game, but at least then, if you start with that, maybe there will be people who, because a lot of people watch the show, maybe it'll be easier for you to find someone who could do some contract work on it and put in features that you might want. Because, hey, one of the nice things about the Handmade Hero renderer is everyone who watches the show already knows how it works. You don't have to learn anything. You don't have to go into someone else's code not knowing what's going on. Everyone who watches the show already knows how it works. So they can just edit it to their heart's content, and off you go. So I said, I would be totally willing. I know that I said that, the game's source code is proprietary up to the point where we actually say it's in the public domain, which we will do. But I was just like, we'll just give you an early license for it if you want to use it. Like, we'll just sign whatever the document is that says, look, it's, you can use it early. You don't have to wait for that. And so really what I want to do today was just go, hey, let's spend 4 hours, clean up the renderer, put it in a little isolated package so that it's easy for our friend to take a look at and compile into their game engine. They already have one that's just a 2D game engine, and play around with to see if it's something that they can make use of in the short term. So that's what I want to do today, and maybe tomorrow. We've got the weekend to do it, so I wanted to get 3 streams in. 6 hours isn't a lot of time to do a good, clean like API pass on things necessarily, but we should be able to get like a reasonable amount done. And so I wanted to do that because I think if I do that pass on it, it'll be a lot easier to integrate in because we have never had that as a concern of ours. We don't consider the renderer, or never have considered the renderer, something that someone else was going to use. We just considered it something that would just be used by Handmade Hero. I also felt like this would be a good opportunity to show what one might do if one wanted to take a portion of a game and reuse it in another game, because that is good technique to learn. It's also how you go from a game to an engine, right? Is learning, or a multi-use engine, I should say. Every game has an engine on the inside, right? But a multi-use engine is learning those skills of how do we take the parts of this game that can be reused and turn them into portions that can be reused without having to have the whole game, right? Without them being wedded to a particular game. So that's all we're doing today, and that's why there's the double stream. So I'm just going to go ahead and get started. There's nothing magical about doing this. You've seen me do things sort of like it in the past, so we're just going to start down that road. And there's a couple pretty easy things we can do to sort of set ourselves up for success there. What I'm going to start with is I'm just going to say, look, let's make a sample program that is, in our imagination, what we would like this thing to look like when you're using it for the first time by someone on the outside, right? Now, I have talked about this before, and I think we came up with a name for it on stream. It's called Snuffleupagus-oriented programming. Snuffleupagus-oriented programming is just when if you've ever watched Sesame Street, there's the fictional Snuffleupagus character that like no one can see but Big Bird. I don't know if they've changed that now. I don't know. Nothing is as good as it used to be, so I don't know if other people can see Snuffleupagus now. But in the old days, it was just like an imaginary friend of Big Bird's that maybe it existed, maybe it didn't. The idea behind Snuffleupagus-oriented programming is just to say, look, let's pretend. So I got a friend who wants to use this renderer or might be able to use this renderer. Let's pretend we're them, and let's pretend we just got the best possible thing, right? What's the best possible thing? What does that look like? Let's pretend we just got that. How would we call it? What would the magical API look like that would make us really happy in that circumstance, right? And so I don't know the answer to that question yet because it's pretty broad. So what I want to do is start by actually putting myself in that situation, writing a little sample code, and going from there, right? Okay. So the first thing we have to consider, let me go to the build.bat here. The first thing that we have to consider is the fact that there's a bunch of Win32 startup code that has to happen to get your OpenGL code initialized. I believe that the target platform for this on the other side, the person who's going to be using it, is actually on a Mac. So that code we can't really help with. They're going to have to they're going to have to know how to start up an OpenGL context. Fortunately, on the Handmade Hero GitHub, there already is the code for starting up an OpenGL context in that way. So for our purposes, we can be a little bit more simplistic about that, right? But what I want to do is start off, if you look here, we have like, for example, our HHA edit build. So I'm going to start another build here, and that build is right here. I'm going to actually do a build of our Win32 code. I'm going to make our own sort of Win32 combined sample app thing that is separate from Handmade Hero as a test. So this is like the renderer test bed or something, right? And so what I want to do there is I'm just going to call this like Win32 renderer test.cpp. And then what I'm going to do is I'm going to go ahead and when I compile this here, I'm going to get rid of the no default lib stuff. The reason that I'm going to get rid of the no default lib stuff is because if I don't get rid of the no default lib stuff, then I'm just assuming that the person who's using this is going to be using the C runtime library. So I want to test it in that sense as well, right? So I want kind of all that stuff to be the way that it is, right? So I'm going to include using the C runtime library there. That's what that is. I'm going to compile this renderer test in. I don't need it to output a map file, and I don't need it to really output anything else besides just the renderer test information. So then what I'm going to do is I'm going to load up and just kind of clone out our Win32 startup stuff. And this is just going to be strictly for the test bed. And again, this is not actually something that is actually going to get used on the other side because it's the Win32 version of it, right? So that's fine, but it is something that I want to just, I basically just want to sort of pull this stuff together into a little test bed that I can at least verify myself is okay. So we don't need any of the D-input or any of that stuff, right? We just need the OpenGL things. So here's a bunch of this code. This is interesting because, this could be an opportunity to sort of simplify this stuff out as well. In fact, I'm wondering, should we kind of even maybe do that first? Because if you look at how this stuff is set up, it's possible that we could share this stuff. So I may actually skip this part for now, simplify that first on the Handmade Hero side, and then pull it over. So all I'm going to do here is I'm just going to do the very basics of the startup that we have. Really, really straightforward stuff. So I'm just going to do the very basics, get a window up, and then I'm going to go from there with our render test on this side, right? All right. So here's our WinMain. Here's our C runtime library startup stuff, right? This one is without the C runtime library, so we kind of want to turn this into a WinMain here. This wants to not be WinMain CRT startup anymore. This wants to be actually just a regular WinMain that people can use. And we can get rid of almost all the stuff that we have here, right? We don't need any of this stuff anymore because it's just not going to be relevant. So most of the complex code that we're actually doing to do advanced stuff, all of that stuff is now not really relevant, right? So I can get rid of all this stuff. This stuff is all fine. We can go ahead and just put this stuff in here. We don't care what the back buffer size is or any of that stuff. So we can just set up our main here, our main stuff here. So Handmade hero, renderer window class, renderer test window class. So what we want to do now, just keep the same code exactly the way it is. We're going to register that class. We're then going to open the window. In terms of opening the window, we really don't care what size it is. We also don't care if it's full screen or not. So we can just open any old window. Again, this is not supposed to be anything like the sort of stuff we're doing in Handmade Hero where we're actually trying to open a full screen or any of that stuff. This is just the basic stuff. We would open, init OpenGL, get rid of all of the multi-threaded stuff, get rid of the sound. We don't care about the refresh rate or any of these things. We're just testing the renderer. So all this code just goes straight out the window. It's not relevant at all. So, okay. This stuff for push buffers and all that stuff, this again is stuff we're going to probably be cleaning up. So I'm getting rid of all of that. We'll clean it up in Handmade Hero first. Don't need any of this stuff, any of the game memory, platform API. None of that's going to be in here, right? It's just the renderer. Then we come through here, texture op queues, those sorts of things. Again, not really relevant to us in this case. Sample memory, not important. So cleaning it all out. Get rid of all these things. We don't care about any of this either. This is basically like mouse position stuff. We may import that in if we want to play with it again. Don't really care about it right now. Just want to open the window. So really all this stuff is just not necessary. We don't care about directional pads or any of those sorts of things at all. All right, so this stuff is game update and render. Don't care about that. So this is like our renderer test frame or whatever, or update renderer test. Would go here. We don't care about audio updating. We don't care about any of this stuff. Not necessary again, because we're not doing any of it, right? So then we get down to checking for reload. Again, we're not doing hot code reloading or any of that stuff. It's just a test bed. So that all goes away as well. Let's see here. So then we got our frame rate. We don't need to wait. We can always just go at the fastest possible frame rate. So that's fine too. Where do we, wait, where's our swap buffers though? I don't think this is it. It's not in here. So here's the frame display right here. So this is where we call the frame display right here. So we want to actually still do that, right? We don't care about any of this. We do kind of want the wall clock stuff probably just to measure things, but I can do that kind of more manually here. So I think maybe what we'll do is we'll leave this where we do an end counter, get wall clock, and then we sort of do a last counter. So I feel like maybe my large integer last counter, that can kind of go in here. Query performance counter. So we can just sort of have that initialize itself properly, and that should be fine. Expected frames per update is not relevant. Measured seconds per frame. Let's see. Let me just get all this stuff in place. We don't care about this. So query performance counter. All right. So where's our win32 get seconds elapsed? There we go. I'll just put that right in here. So I think that's really all we need to know. Here's our global perf frequency bit here. That's a U64 for the quad part there. The get wall clock, like I said, is just this function, so I just expanded that out in line. And that's all I really want. So we can get, this just gets us our frames, our seconds per frame there. Round real 32 to int 32 is just there to, to look at our target frames and our expected frames. Again, we don't care about any of that stuff. So our measured seconds per frame is all we really care about. That gives us basically a millisecond count. It's in seconds, but it's going to be 0.0 something. It's going to give us our count for each frame, which we'll probably want to do just to make sure we're running at a reasonable frame rate, right? So again, looking at this here, we're pretty good in terms of what we're looking at here. I'm just going to put WS visible in here so that our window is actually visible. I'm then going to nerf the two things that show up for OpenGL, right? Like so. And I now need, if you look at what's going to go on here, and we can start running this pretty soon, but we're going to have some things like I said, we have to process window messages and stuff like that, or nothing's going to happen. So we got a few more things to do, but I'm just going to go ahead and sort of nerf these things out here, and we'll kind of go. So we'll kind of take it as we go. So I'm going to go ahead and put a while loop in here for while global running. We're just making sort of a silly little program here that will never exit, that opens a window. We'll just start there, right? We'll just start there, and we'll finish, as we go. So all right. So what do we actually need to complete this, just to get things going? We need our main window callback, right? Which is this. So there's our main window callback. And when we come in here, right, we do have our WM closed message, and that's going to set that global running flag to false. I need to actually put this global running flag out in the actual globals. Well, I don't need to say that. So when we look at what's happening here, you can see all of this stuff is kind of weird code for maintaining an aspect ratio. We don't care about that at all, right? So this is really not relevant, right? We can get rid of all this stuff. Does not matter. Set cursor is also not really relevant to us. That can just pass through. Activate app, not relevant. All of this stuff is correct. We do want to exit in all those cases. Don't care about syskey down or any of those things. Don't care about paint, other than to just make sure that it updates the recs, doesn't keep sending us the message. So most things can just go straight ahead to our def window proc, and off we go. So I think that's all good there. And then so really all we need is our win main here. I don't use win main very often, so I don't really remember what the win main entry point signature even is. So I'm just going to grab it. Here we go. Oops. And if you look here, if you're actually switching back to win main, we don't need to use this get module handle 0 because we just have the H instance there. So I'm just going to go ahead and set it up like that. Turn these into things that humans can actually read, and then we're good to go. All right, so let's start with a few things we need to do. First of all, we don't have any of our types in here. So what I would like to do, if you look at handmade platform.h, one thing I've been wanting to do for a while is there's kind of just a bunch of things in here that you might want to use in a more general sense. that I kind of want to pull out into a handmade sort of types. I kind of want to do this for a while, like something like handmade types.h, right? And what handmade types.h would be is just something that has, you know, like a pretty straightforward understanding of all of this stuff, right? So, you know, we would imagine just putting it in here. And then all of these things just kind of come out, all of these basic calls, right? And then all of these basic math things, like so. And they're all going to be out there. Then we have kind of our understanding of how we do like asserts and not implementeds and all that stuff. All of this stuff is just kind of our basic information, right? Like nothing super complicated here, right? So I kind of wanted to put all that out there so that you can pretty trivially do just the basic operations that you might want to do. We don't really need any of this other stuff. This is all specific to Handmade Hero, right? But all this stuff actually isn't. It's just things that you might want to use. So I wanted to kind of put that out there. I may want to put the mutexes in as well. I'm not 100% sure about that, but we'll see, right? So then we've kind of got this way of just saying, all right, anytime we want to build something to that effect, we can just say, all right, include handmade types.h, and then we'll get all of those types that we normally use. Now, this stuff was for our introspection. We're not really doing that stuff anymore, so I'm just going to get rid of it for now. And go from there. Okay. So I, for some reason, made global variable be the thing that we use here. I nowadays just use global. So I kind of want to say, look, global is variable is just redundant. I'll just might say global. And then what I'll do is for now, I'll just get rid of that usage. You can see I put it in forcoder as an auto highlight even. That's the way I used to talk about it, is just as global, right? And so that's all I'm doing here. Nerf that for a second. And yeah, now I can just kind of clip these out. I'll do this with search and replace, just a little bit faster. Let's see. Looks like this one can also be a little faster that way. There we go. Okay. So now we're good to go. And, oh, no, we're not quite good to go. Try that one more time. There we go. So, also in theory, you know, again, I'll just double check, but in theory, we're not changing anything about the code, right? Our game still runs just as normal. What I want to do here is I want to now get that little test bed up and running that's totally isolated, so we know exactly what we're using and we can write the test code the way we want. What I'm going to do here is I'm going to do something slightly different from how we've done it before. This is the way I've been doing things now. It's sort of a change from the way I used to do it. What I used to do, and you've seen me do it, is I just opened just the bare executable, right? And this is good because, you know, that way you can just run. You don't have to have a project or a solution in Visual Studio, but it ends up creating a solution on the back end anyway. I don't know if you've noticed that, but it does just to save the state. But you can't actually use any of the features. So for example, I can't have multiple different arguments I might run with and set them as different configurations, because when you just open executable, you can't do that. Don't ask me why, you just can't. So what I kind of figured out is a better way to do this is if you actually create an empty project, so a project that has nothing in it, what you can then do is say, all right, well, look, in Handmade, MSVC proj, which will just be some temporary directory that stores these kind of projects. If I have Win32 renderer test as one of my projects, right, I can just, and turn off create directory for solution. I hit OK here. I get an actual project, right? And when we look here, it keeps it isolated in here, right? I like how I said don't create a directory for solution, and what does it do? It, of course, creates a directory for the solution. I did that right? I didn't screw it up, did I? Let's just make sure. Because we don't need it to put it in a directory, but, you know. Let's just make sure I'm not hallucinating. Project, empty project, do not create directory for solution. The location is here. The project name is Win32 renderer test. Right? Right? We all see it? Okay. I hit OK. Creates the project in its own directory. It's so weird. Like, Microsoft is in their own special universe where the checkbox for create directory for project, when unchecked, still creates a directory for the project. They're like, hey, we'll take that under advisement. And then just totally ignore it. Anyway, but this is what I do. I delete all of the stuff that it puts in there, right? Like, basically everything. And then I just use this fake project by saying properties debugging. Rather than this, I just say, hey, I want you to use Win32 renderer test as your executable, right? Then if I step in, yes, build my project, right? Then if I step in, it just works exactly the same as it used to, right? It's the same as what we had before, but now you can actually make configurations of the project. So if I want to make a bunch of different configurations here that have different command lines, different execution directories, you can. So it's just a little bit of a way of making Visual Studio be a little less crappy for debugging external things. Now everything sort of works, right? Anyway, here's our window. You can see I can't do anything with it. Why? Because we literally don't handle any messages, because we never actually process messages. Now, sometimes we'll get them directly sent to the window, but other than that, we'd never get them. So let's finish that up so we can start actually coding the renderer test by just actually having a place to process our messages. Again, we can just copy this code from the Handmade Hero side of things. So we've got our peak message loop, right? I think we decided that this stuff was kind of just nuts and we had no idea what Windows was actually doing here. We still don't really know what Windows is doing here. It's kind of ridiculous, but I'm just going to copy this process pending messages stuff out to here so that we can call it. And then I'm just going to delete most of the stuff that we're doing. So we don't care about keyboard or anything at the moment, so that's gone. We don't really care about anything other than just the quit message and the dispatch stuff here, right? So that should be fine. Okay, so I think that's all we need. We don't need any of this. Pretty sure that'll just work. We don't need to time anything. So I'm going to go ahead and call this Win32 process messages in our loop here as well. Okay. So there we go. And now when we run this in theory, we should be able to kind of like size the window or do the other sorts of things you would normally do with the window. So now we're ready to actually start calling the renderer, right? And what I'd like to do, and you can notice it closes as well, which is good. What I'd like to do here, again, is I'd like to make this sort of easy to use. So I'd perhaps like our Win32 init OpenGL. I'd kind of like that to just be able to, I'd like to be able to do here, fundamentally speaking. Also, I don't know why we need to get a device context here when we already have a device context here. Seems kind of dumb, so I'm just gonna stop doing that and say that this will use the OpenGL DC. So what I'd like to, because remember we have CS own DC here, so when we get that handle, we can just keep it. It's not a problem, right? So anyway, what I'm going to do in here is I want this init OpenGL stuff to work kind of cleanly so that I don't have to copy and paste all that code in there. So the first thing I want to be able to do is pull out the OpenGL initialization stuff into its own separate file. So for example, in here, we've kind of got, if you look at our OpenGL, there's all the OpenGL code. It's the OpenGL code that's shared across operating systems, right? So I want a Win32 handmade OpenGL. That's what I want. And I want to pull out all of that OpenGL code. Oops, it's the same thing we already have. I want to pull out all that OpenGL code so that we can just reuse it in here. And I may also want to simplify it so it's easier for people on other platforms. I know it's been a little bit tricky because we haven't really thought much about that. We haven't done anything to help those people who are porting. And we could start doing stuff like that right now that we're taking a couple streams to clean this up. So what I want to do is I want to pull all this code out. We know this code is just for OpenGL. Nothing else is happening in here, right? This is all OpenGL code. So it's going to pull all that code out. Here it is. I'm going to put it in here, right? And really, this is the H file portion to a certain extent. So we may kind of want to do it that way, but you know, 6 of one, half dozen of the other. We'll see how we want that to be going forwards. I also should put our little boilerplate in there. So we're going to include this, obviously, right? We're going to include Win32 handmade OpenGL.cpp. And if we build now, we should be able to get this building again, like not the new code, but the old code, because we're not making any serious modifications to it, right? We're just doing straightforward reorganization of where the code lives so it can be used by different people. So that's pretty straightforward, I think. All right. So where's the rest of the OpenGL code? Well, we've got these attribs here, right, that we know we might want. Global array. We've got this set pixel format and load wiggle extensions, init OpenGL. That's this whole bit here. So all that stuff kind of wants to be in the OpenGL side. So let's see what we have to do to pull that out. It may be nothing, it may be something. You can see there's some stuff here that doesn't like, right? So what's going on here? Wiggle context major version arb. The problem here with that is those weren't defined anywhere. I think, is that because they're in here? Know where those went. Yeah. So these really shouldn't be in here. I don't know why they were. I guess we just forgot that they were Windows specific because this is where the Windows specific stuff goes. So let's try that again. All right. So that all looks decent. Let's start here. Here's our OpenGL supports sRGB frame buffer. This is a tag that we're supposed to be getting back from the OpenGL layer, right? And we don't necessarily know. So that's an issue. We can think about that. We've then got some problems here where we want to sort of crack this open, this wiggle extension stuff, where we look at wiggle extensions and override some things in our OpenGL settings, right? So that's a little bit of an issue here. How are we going to deal with it? So just keep those in your head. We're not looking at them quite yet, but we're going to very shortly. Then we got this info structure where we need to look to see what sorts of stuff we actually need to wiggle get proc address for, right? Are we using the frame buffer object or not? Those sorts of things, right? And then it looks like we're kind of okay. OpenGL init then at that point is sort of the platform, the part that doesn't have anything to do with the wiggle section of things, right? So in order to get this working, really all we would have to do is make sure that we always install, like we always like include the actual Handmade OpenGL side of things. And you can see that does some things like pulling in render group and stuff like that. So we've got some stuff we're going to have to do as we start to walk down this road, but we'll cross that bridge when we come to it. You'll see in a second. All right, so for starters, what I want to do is look inside Win32 Handmade. I want to see how that inclusion pattern went. So if we look here, you can see we have Handmade OpenGL is included sort of in here. And you can kind of see it doing this like, oh, then I define it as a global and then off we go. And there's sort of this weird like sort of alternating pattern that's going on here. And this like kind of needs that to happen inside it. And all of this stuff kind of has to play out a little bit more sanely there. What I'm going to start by doing is I just want to analyze what we actually do and don't need in these things more specifically. Okay? For starters, suppose I were to move this down here. What happens, right? Just to see what the dependencies are, right? And what you can see is actually not much. This just needs these two functions to be provided to it now once it actually can see those. What that means is we could pretty trivially, to like move forward on this a little bit in sort of slow baby step fashion, is just take those two functions that we actually care about here, the OpenGL init and getInfo. So this one. Behind my head there, and the getInfo. So I can leave these two modules talking to each other this way and continue to move forward, which is what I want to do. I want to simplify how those things come together. So I don't like that yet, but I don't want to address it yet. So you can see I'm doing this in very specific steps that move things around so that I can still run and compile and see how things are related more easily without taking a big leap, right? So that's very intentional. So now if I go look at this Win32 init OpenGL part, what you can see is that I now could call, if I wanted to, the same pattern of includes that's happening here. I could actually do that like this and be okay. Now the problem is Handmade render.h and render.cbp are probably not going to work. Because of dependencies that we aren't doing, right? Like, well, v2 was supposed to be defined. So I'm not sure what's going on there. Hold on a second. Let me double check that. Types.h. Did I put that included in the wrong place? I did. Sorry. Where's the win? Did I just delete it? It was here a minute ago. I don't know what happened there. So you can see, right, like inside Handmade render, this stuff is just intermingled with like the game render commands and all that sort of stuff, right? And we don't really want that to be true. So I don't actually know yet to what extent I can extricate those without doing more work. So that's kind of more what I'm interested in. Like, for example, if I get rid of this, what do I lose, right? And you can see, well, it's got this render settings. So what I could very easily decide to do is move that render settings more into the renderer, like into an understanding of what the renderer proper actually is, and sort of extricate it there. So that's a really good sign of the first place I need to start making those changes, right? And let me get rid of this as well and see where we're at there. So you can see the current settings seem to be the really big hang-up. So looking in here, you can see we also rely on sort of a printf because we're trying to generate there basically some versions of this stuff that use parameters that we don't know. So we're kind of trying to set some parameters here dynamically. So that format string is kind of also something that we need to address. Now, fortunately, we don't really need to do that much. For that, we can pretty trivially just say, oh yeah, you wanted format string, that's fine. format string is just printf, sprintf. So, you know, the size in the string, or the size in the dest, we just skip the size part, put the dest in there, and then put the VARGs on the end of it, right? So we can pretty trivially make that happen. We can also use the sized printf if we want to. So that really doesn't concern me. That's going to be pretty easy to handle. Yeah. So then we've got some other things like strings are equal. Again, those things we can easily nerf for the time being, just to move forward. If we want to do two strings, that's just a string compare of A and B equals 0, right? And so again, we can kind of keep those pretty much under control. So let's take a look at what else we've got going on here that seems problematic. It wants us to use sprintfs. I don't know if I want to use sprintfs, but I don't really care. It's fine with me. So that'll take the size, which is fine. That's what we were doing. Just takes them in the opposite order. So if it wants to do that, go nuts. And so it looks like those settings are really most of it there, right? So we kind of know where we're at here. It's really not that bad if I don't want to include that render information. If I'm just talking about these things, it's not too bad. I don't know about the sort. I don't know if anyone actually calls that. So I'd be interested to see if any. I don't think anyone probably does. So I think we're probably almost to the point where this would work. And really what we're worried about here is some of these things like the render settings and like that, the loaded white bitmap sort of way of short-circuiting the fact that when you want to draw without a bitmap, it substitutes that in there. Okay, so looking at this stuff, we've got a few string things here that we use when we're analyzing the extension stuff. This is really, really ugly, and this is OpenGL's fault, make no mistake about it. This is in no way an acceptable way to have people look at extensions. I mean, it's just ridiculous that you're parsing strings to look at extensions. So error prone. It's just absurd, right? At the very least, just say how many strings there are and let me enumerate over them. And thankfully, they did do that in future versions of OpenGL, but of course, Wiggle is old and doesn't conform to that anymore. You have to use extensions if you want to get things as a set of strings like that. So anyway, taking a look at Handmade render group. So we've got some things here that sort of use like loaded bitmaps. So you can kind of see, we look through here and we look at like what our problems are going to be if we want to share, if we want render groups definitions to sort of propagate through here. We look at what problems we're probably going to have. And what you'll notice is there's really not a lot in here besides loaded bitmap that's really a problem for us, right? Like loaded bitmap's really the only sticking point. I don't know if anyone uses environment map. I'm going to look and see if they do. So if we look down here, if I just nerf this and say no more environment map, like so, I want to see who cares, right? So this stuff is just not used at the moment. So I'm gonna just nerf this as well. We just fundamentally don't use any of this stuff. It was some rendering experiment stuff we used before, right? So I'm just gonna get rid of it. Yeah, you can. I mean, you can just see this. This stuff is just. I mean, it's just nonsense, right? just old stuff. I mean, this whole thing is not necessary. Just old stuff that we never got rid of. Yeah. All right. So I think that's all good. This is just from the renderer test stuff, right? So getting rid of that environment map is just fine, right? Like, nobody cares about that. We can remove that entirely if we want to. It's just not a thing. I'm just going to look through here and see what other sorts of stuff we have to deal with. Rectangle 2i, I'm not sure where that's defined, but we can put that into our types because that's also a type sort of thing. So let's grab that out. Clean these up eventually too. Let's take a look. So no, not care about that. M4x4 inv. Assume that's also in math. Yeah. Pull that out. That's just an M4x4 with its inverse together for convenience. Excuse me. Again, loaded bitmap is there. What's this? Illegal use of this type as an expression. Oh, that's just, yeah. No, we don't care about that at all. S32 from Z. So S32 from Z is our little parser there that can turn, that can parse numbers. Again, that's just A to I, so we can also, again, temporarily, we can make that be something that we're gonna stub out. Okay, and so then we've got some like calls on the rectangle 2i. Those would be nice to have. We got the safe ratio. So that's just using our math library now, which we want to include, and we want that to be pull outable. That'll probably be our next step. So then we've got to start thinking about like the texture ops for allocating textures, those sorts of things, how we want those to go. We can think about those a little bit more in depth, but I'm just trying to look through here. So this looks pretty reasonable, right? This is all, none of this is particularly scary to me. Everything looks pretty good in here. All right, so in order to get us back on track of being able to compile the Win32 renderer test without the rest of Handmade Hero, what I need to start looking at now is taking the parts of the renderer that are embedded in other things in Handmade Hero and pulling them out into their own thing, right? So if you think about what OpenGL is like a back end to our renderer, right? And so we want, and you know what, I should get math in here as well, right? So these are things that people will use with the renderer. We want the types.h, right? And you can see that that is now pretty straightforward, right? The types.h is just a very simple file that just has some very basic things in it in terms of, I could clean up these types so they're concise as well. It has some very basic things in it. Those things are just the way that we write code. So anyone who's going to use our stuff has to be familiar with it. That's totally fine. And so that all is reasonable. I might want to clean this file up a little bit into break it into sections, but there's nothing really wrong with it. It's fine as it is, right? So the next thing I want to do is take a look at math and see to what extent that is also okay, right? So I'm going to take a look at the math. Here's our math.h. And let's just look through that. It's pretty clean, just sets of math ops. There's nothing weird in there really. So if you want to use our math, I think you're pretty good to go, right? That all seems pretty fine to me. So let's see how that goes. And so these are the intrinsics. And again, that all seems pretty good too. So I think all of that's fine. Now we may want to weld some of those things together. We'll have to think about how we want to do that exactly. Let me go ahead and grab this out here. Where are those things? Where do we include XMM in Trin? Oh, here? No. It's in here, as it turns out. Well, what I'm going to do for that, since I want these to be out here as well, I think what I want to do is kind of get these pieces here. I think I kind of want those to come out here, and I want this to be inside here, right? There we go. All right. F32 max, I'm not sure where we defined that, so we'll have to grab that somewhere. It's in platform. Oh, so we have the maxes. They should all be out in that types file as well. Yeah, that stuff should all be in here. There we go. So again, that all seems pretty fair. So now you can use all of the math stuff, which we also want. We want to be able to ship the math stuff out. We want to be able to ship the types file. And yeah, all of that stuff we kind of want to just work. And I think it should relatively good, right? Yeah. So then, like I said, I think we're down at that point just to stuff that really needs to be this is all the errors that there are. In fact, we're not even at the 100, the thing where it's like more errors than I can display. Oh no, right? So in this case, I think we're in good shape. I don't know how much time I have left in this stream, so I've got another entire hour left. So what I'm focused on here now is I want to pull out the renderer into sort of its own, more of its own proper defined thing, because that's what we're going for. We're trying to extricate it from our program and say it's no longer intermingled. It can just stand by itself, because it was already kind of architected that way. Like, we didn't really make it particularly hard-coded. Like, it's fairly standalone as it is, and that was because OpenGL was kept to the side. Like, we don't sprinkle OpenGL code throughout our app, so we kind of already did a bunch of that anyway. So now the goal here is to move more towards that. And so we have a couple things about our renderer, so we've got this notion of render group, and then we've also got this notion of render, right? And you can see that they're kind of weirdly separated, and I don't really like too much about the way these go. They're sort of flipping things. There's just too much kind of chaos there. It's unclear who's doing what. And if you look at how these are broken down, Handmade Render is weird, because Handmade Render actually has all this. It's really the software renderer that ended up in here, as well as some renderer stuff, right? So it's just these two files we never really cared much about figuring out how they go. So what I want to do is I want to start by breaking these up into what was actually the software renderer should now be its own file that's completely isolated to software rendering. And so much like we have Handmade OpenGL, right? What I want to do there is I want to have Handmade like software renderer, okay, .cpp or something like this, right? So I want to specifically say that the software renderer lives in its own file that's like a different thing, and I'm just going to grab anything I see that's just obviously software renderer. I want those things to go into this file, right? So we know that our IACA stuff where we were doing profiling, that was obviously meant for this situation. So all this stuff should have gone in there, right? I don't know if global render show loading samples, I think that's a separate thing. So draw rectangle is obviously one of these, right? Bilinear sample, SG, like all this stuff, sample environment map that we nerfed, all of this is all software renderer. Draw bitmap, right? Change saturation was, I guess, some kind of a post-pass thing, or draw matte. Yeah, you can see all these things. Draw rectangle quickly. These were all software render features that we implemented there. Blend render target, clear rectangle, render commands to bitmap, do tiled render work, software render commands, all this stuff, right? All that stuff is actually the software renderer, okay? And what I might do, I might even do some renaming here. I apologize to people who like to count on the names of files for things. I know it's not great. But like if we do handmade renderer something, handmade renderer something, handmade renderer something, maybe that helps to say like what's going on with them. So if I were to say, for example, let me just save the stuff that we just did. So what I kind of want to do here is say, okay, like if I go to handmade code, maybe what we do is say, look, the OpenGL renderer and the software renderer are kind of like two branches of the same thing. Not branches really, but two versions of the same thing. So what I'm going to do is I'm actually going to name them as such. So this is actually going to be Handmade Renderer Software, like so. This is going to be Handmade Renderer OpenGL, like so. So then you can kind of see, like we've got the OpenGL renderer, the software renderer, and then here what we can do is say these things will merge together into like handmade renderer.h, so that there's like the renderer, then there's the OpenGL implementation of the renderer, there's the software implementation of the renderer, and eventually we can do like a D3D version of the renderer and a metal version of the renderer, right? This is, again, some pretty straightforward stuff, right? Nothing particularly weird about what's going on there, but just worth understanding what I was trying to accomplish with that, right? So now what I want to do is merge these two files, render and render group, into a single file that's just renderer.h, right? Oops. So I'm going to load that up. And so render.h, I'm going to grab this whole thing, put it in there. Then I'm going to grab the CPP file and do the same thing. Put all that in there. And then what I want to do is grab render group. And again, do the same thing. Like so. And then, again, same thing here. Okay. So now I've just got those completely sort of by themselves. I want to quickly switch, just really do a simple switch here to not compile our test code now, just so I can focus on making sure our other code builds. So what I'm going to do is I'm going to change these things that used to refer to the old files. And I'm going to make sure that we can include them here, right? Oops. Like so. I think this is what we want to do. I don't actually know if we want that. We don't, I don't think. Well, maybe we do. I don't know. We'll see. We'll find out. Okay. So what I want to do is I want to get rid of everywhere that that includes rendergroup.h. So rendergroup.h, don't want it ever. It's not a thing anymore, so we got to deal with that. Render.h, also not a thing anymore, so we got to deal with that. So anywhere that was getting included, it needs to stop getting included, and then we can go from there, right? All right. So looking at here, we just have I think this is probably just a case of get bitmap not being included at the right place. Where are we inside Win32? Handmade. Why isn't that just in Handmade renderer? I thought that's what would have been in here. Get bitmap. It's not. Where is get bitmap? That's weird. It's in Handmade asset. This we will want to untangle. We will definitely want to disentangle this, and we can sort of see how that's going to happen a little later on. But for now, what I'm going to do is just going to forward declare it. Same with load bitmap. Should be like right here. There it is. And these are, let me see about load font. Again, this is kind of just patching. So I'm not really going to leave it this way probably, but I don't want to disentangle those things quite yet. What else we got? Loaded font. And get font. Okay. Okay. So one problem we're going to have here is if those were for including specifically the renderer.cpp. So I don't know to what extent we could just not do that. I'm going to double check to see what we actually need from there. But really we just want to disentangle those things too, probably eventually as well. So yeah, so it's only aspect ratio fit. So really what I probably want to do for now is, if I can get away with it, and let's see if I can, to just not, like, how much can I get away with not having these? Entirely. Okay, good. So aspect ratio fit we still need to have, however. So what I'm going to do is just take aspect ratio fit, and since that's just a math operation, that's all that is, I'm just going to put that into the math library. And then I think we're good to go, right? Okay. Oops, that's not what I wanted to run. So I just want to check to make sure everything's still running okay. And it is, so that's good. Close this down. Oh, I don't need to close that down. Why did I do that? Just need to switch it back to the other one. There we go. So what I want to do at this point is I want to now ping pong back to the other test bed, and again sort of progress down that road as I was beforehand, right? Okay. So here's our renderer OpenGL include. We need also the Handmade renderer OpenGL here, like that. Handmade renderer.cpp doesn't need to be included yet, so we'll talk about that in a second. This actually should be in here. Okay. So now we need to start looking at the things in Handmade renderer that are actually sort of wedded to we need to look at the things that are wedded to the platform layer, right? And we need to figure out how those are going to get pulled out and how we're going to look at them. Now, if you remember correctly, inside the platform layer, we have these game render commands and these game render settings and these texture vertices. These are all obviously just renderer things, right? These should actually be defined in the renderer, and as we start to simplify them, we will take more charge of them. So these are not really in the, these actually should be in renderer.h now, because that's actually the stuff we're going to be dealing with, right? So as we clean these things up, we want to start cleaning these things up too. I don't know about the game off-screen buffer. That's not really a thing. That's sort of a separate part for the software renderer, I think. So we need to kind of think about why that is even out here in the first place. Kind of a good question. But this stuff here wants to be moved into the render definition almost certainly, and worked from there. Now, nothing else in here is particularly related to that, I don't think. This is all like input and memory allocation and that sort of stuff, things we don't care about in that sense. So I don't know, like, I'm going to go ahead and search for what that off-screen buffer, who uses that still? So it's only in Win32 Handmade here for this. So I kind of feel like that, where does that get passed through? Can't see anything, my head's in the way. So that's a Win32 off-screen buffer. So game off-screen, you know, I'm just going to go ahead and see what happens if I nerf that thing. I also need game render settings in there. Let's do that. Oops. Like so. So these actually need to be defined somewhere. And in fact, this stuff is not really where I would like it to be anyway. I feel like this stuff should have been in here to begin with. So I'm going to move this out to some place that's actually doing comparison calls, right? And then we take this our equal bit for the game render settings, and I'm actually going to put that into the renderer because that's where it belongs, right? We could put it out here. I don't know where we want to put it exactly, but right. Okay, so again, this is temporarily speaking. We can look at that as a pre-def, and then we can kind of go from there. Loaded bitmaps we can also look at as a pre-def for the moment. I don't know how long that'll hold up. So inside our render test, you can see all this still works here. We've got our light data width stuff. That was in the platform layer as well. It should have been moved out. Didn't we? Where's our light data width? Where's that stuff defined? Light data width. So that's in Handmade lighting. I say. So I'm not entirely certain how we want to deal with that. For now, I think what I'll say is that is going to get put out here temporarily. I don't want that to stick around forever, but for now it's totally fine. So now we're mostly down again to sort of things that we were using in here. I don't know how exactly I want these to work. So we're just going to kind of wing these for now because I don't want them to be really something that we're focusing on. But for memory is equal size AB. I don't know why these weren't capitalized. This can just be a memcomp 0 AB size. I believe should do it. Is white space string comp? So string comp. We actually, I see. So string comp, we actually have two versions of, one that takes a size and one that doesn't, right? So that's actually string encomp, which I believe exists. I'm not really allowed to define those. Looks like multi-define them. So what I'll do is I'm just going to stub them out like so. So again, nothing particularly spectacular happening here, but I just don't want to deal with these at the moment. Go. Yeah, that seems. What is the problem? Oh. So this wants care stars as well. I don't know why I said void star. There we go. So we just need is white space and zero struct. Again, those are pretty easy to deal with. So I'm just going to go ahead and do them. Light buffer. This, instead of using zero struct here, I think I might just do this so that we don't have to worry about that. And then is white space is pretty straightforward as well. I don't know if this exists in the C runtime library. It might. It would probably be in like the care cares the care.h or whatever it's called. C type is space. What else you got for me? This is the character classification stuff. So I think that's all we really need, would be is space. Right? It seems pretty straightforward. Oops. So what I'm going to say is white space is just is space. See how that goes. So now I think we're good. The only problem we have here is this in Handmade lighting. I think this now, oh, well, that's including rendergroup.cpp, which is not supposed to be, so that's probably it. Where is rendergroup.h being? So shouldn't that have taken care of it? Because renderer.h is what has it in it, right? Renderer.h. There's light data width right there. And it's getting included beforehand. Oh, you know what? It's probably just inside the Win32 Handmade version, because remember, those get built separately. That's almost certainly the problem right there. I also don't know if Handmade lighting actually needs to be in there. Does it? So this right here needs to allocate lighting boxes and it needs to know how big those are, right? Apparently. Which is a little weird because the platform layer doesn't really need to know that much about those things, but okay. I mean, I'm sort of okay with it. So for now, I guess I mean, the lighting never actually, like, this doesn't really need to be here, does it? Like, this doesn't flow through to the, that doesn't really flow through to the actual renderer. Like, isn't that something that should be done as part of the game side, you know? Because it kind of feels like it. Like, it kind of feels like that really isn't part of the render in that sense. So, 'cause, 'cause it kind of feels like it. Like, it kind of feels like that really isn't part of the render in that sense. 'Cause, 'cause it kind of feels like that really isn't part of the render in that sense. 'Cause it kind of feels like that really isn't part of the render in that sense. 'Cause it kind of feels like that really isn't part of the render in that sense. So if we go into the renderer here, and I look to see, does anyone ever look at the light boxes part of things? I'm pretty sure the answer is no. Oh, whoops, it's not what it's called. It's called OpenGL Renderer, right? Or, sorry, Renderer OpenGL. Light. Because it never looks at those. So that's kind of wrong to me. And I don't love that. Because it should only really exist during the portion of time. Like, I think that needs to get cleaned up, I guess, is what I'm saying. Because at some point the light data gets set, and that's all there is. And you don't really need to look into it in the way that this is having it look into it. So I think I'm going to go ahead and get rid of that. So rather than clean this one up and patch it for now, I think I'm going to actually focus on getting rid of that. So here's the renderer. And we got to go through and start cleaning this up. But before we do, this lightbox count lightboxes thing, I feel like that's got to go. I just don't feel like that's an appropriate place for that. I feel like the appropriate place for the lightboxes is actually in just the standard render group that's actually having the push, that's actually pushing stuff on here. I feel like this is actually where that should be because it's only relevant for the path. All right, sorry about that. OBS just crashed. Fortunately, I noticed, so we didn't really lose anything. This is where we were, but okay. So hopefully the recording is intact. I don't know if it is or not, but hopefully it'll actually be salvageable, or at least for the most part salvageable, and these two could be welded together. Anyway, what I was saying is I wanted to put the light boxes in here because they really only exist for the amount of time that they're relevant to the render group, right? And so what I'd like to do is say when you enable lighting, then you can push light boxes, and if you don't enable lighting, then you don't, and that's all there is to it, right? So the light boxes, I just want to have them be gone. So in here, where the operating system previously was allocating light boxes for you, I don't want it to be allocating light boxes for you. What I want it to do instead is to have those come directly from here. Like so. So this way the light boxes come out of the render group, which is where I wanted them to come out of, because they are computed CPU side at the moment, and until we actually know what we might, like if we eventually do computation of lighting on the GPU side, that's fine, but we should figure that out first before we start sending them down to the card or something. Like we kind of had it set up as if we were going to send these down to the card, but we're not sending them down to the card. So they really should not be in that part of the code at the moment. That's my opinion on that. So this right here, when we do the lighting test stuff, that's going to just use the group information directly. So this group commands thing, it's not going to have to deal with that. The light point index, I don't remember to what extent that is actually used inside the render itself. It might not be, I'm not sure. Let me just take a quick look at that and see. So I don't actually see that. The light point index is just an index. So that also can just come out, I think, right? That can just be done in here, and we don't have to deal with it elsewhere, I don't think, right? So I believe that just means that this transfers into a group thing. So does this. So does that. And then that's all coming out of the right place. This is now just looking at the group exclusively, which is what we want. And I don't even know if it needs that anymore. We just find out. All right. So now what we need to do, though, is actually allocate those, right? So those do have to really get used. So, you know, we now have this code when we go to start the render group up. So in here, where we actually initialize a render group, so in here where we actually initialize a render group, what we want to do in this case is we want to initialize the lighting information as well, because otherwise we'd never get any, right? So we can start off with it being pointed to 0. When you do enable lighting, though, when you make that call, that's when you actually would have to allocate memory for it, right? When you come in here now, you'd have to set these light boxes to be something where you actually are going to use the memory, right, for them. Problem is, when we call enable lighting, we haven't passed it anything with which it can get memory, and so that's an obvious problem that we need to rectify here. And so that's what we're going to do now. In world mode, which is the only place where enable lighting actually gets called, you can see here where we do a enable lighting, then we push the lightings on, and yeah, whatever. Yeah, this is because we put them on the stack so they're transferred first, and then, yeah, it's kind of nuts the way that happens. We can probably make that a little bit clearer too. Anyway, when we do enable lighting here, and then the push lighting call happens, this should probably just be one and the same. When you enable lighting, it should just push the lighting. That's probably what should happen. Because you can't do it any other way, right? I mean, that's how that has to work. So I think what we might want to do there is just combine those two. So if we take a look at the push lighting call, which is this part right here. I don't know why push render element is defined like only right there, but it is. So, you know, there you go. So I'm going to just take this whole bit. I'm going to move that down here. I'm going to say enable lighting is just going to be push lighting from now on. And so what you're going to do is you're going to pass the bounds and the light source there. This right here will happen in here. And then we'll get back to the part we were trying to do before, where we were talking about where we're going to get the memory. So when we do the push lighting here, then what happens is eventually when we're done, we do a lighting test thing. That's sort of like when we retire the lighting. So from here to there, that's sort of the lifetime of it, right? Now in here we should have a transient arena that we can use, and we should be able to have some sort of a temporary way that we can allocate some lighting on that and then move along, right? So I believe if I go look, where's my begin sim call? Yeah. So I believe if I go look at my begin sim call and how that works, right, you can see how it just does a temporary, it starts a temporary memory thing. That's really all I want to do here too. So inside where we do our lighting, I I want to do the same thing, right? I know that the transient arena is a fine place to stick the memory for the lighting because it's just stuff that gets used temporarily. So what I should be able to do here is where I do a push lighting, I should be able to sort of do a light memory like so, and I should be able to do an end temporary memory, light memory like so, and this can just be tran-state, tran-arena, or whatever, right? Yeah. So what I want to do is when I push the lighting there, then we come down here, and then we've used the lighting, and so we can end the temporary menu for the light arena. Now, this sim here is actually going to have its own temporary memory, so this is just, really we could just do temporary memory for this whole thing, and we probably should just unify those two together instead of having an open and close the temporary memory like that for no real reason. But it's fine. I thought we just looked and it was. Oh, it's not called that. It's called Tran Arena. There we go. Yeah. There we go. So now what we need to do is make push lighting actually do that allocation. It needs to do that allocation in a sensible way. If we go into the render group, right here, we don't want to be calling win3 to allocate memory, obviously. What we want to do is call push array. We need to pass the array size and the thing that we're actually using here. We don't care about the not restored bit at the moment. That's sort of a separate issue. So we can put that in here, and we can put that into the temp arena. So what I'm going to do here is just say we've got a memory arena, and off we go. Now we need to look at the push lighting call. That is defined there. Wait, there's another one? Is that a bug? That might be a bug. We're not supposed to be calling that twice, are we? Oh, and that's in the wrong one. You know what I need to do now that we're doing this? I need to get rid of those other files. There we go. That seems like a bug. Hold for one moment while I remove those other two files also. I'm just going to get rid of them real quick so I don't accidentally edit them again. Right. So we want render group and render. We want these to go away. So it's going to pop out here. I do this sometimes. I'm just going to make a retired folder. This is where old files go to die. So what I want to do here is I want to just go ahead and find out if that just seems like a bug we just didn't notice. I don't think we're supposed to be pushing those on twice. I'm nervous about that. That does not, unless I'm forgetting something, I don't think push lighting is supposed to happen twice. Right? Yeah, I don't know what to say about that. I'm gonna see what happens here, but that just seems real bad. And I don't know what's going on, so I'm just gonna go ahead and pretend that that's okay and nobody saw it and it's fine. We'll go ahead and debug it and see what's going on. But that was weird. Okay, so we know we want to initialize to that light point index, because light point index 0 is an unused one, I guess. Lightbox count needs to get initialized to 0. It will be, because it automatically, when you do a push lighting, it automatically was initialized to 0 just way back here in the group already. So I'm just going to assert that group lightbox count equals 0. because I don't want people calling push lighting twice, since obviously that's something we might do. And I don't think we're supposed to ever push lighting twice. We're only supposed to push the lighting once. Now, we could do a thing that when you push the lighting again, it just resets your lighting, and that's fine. But at the moment, since we're not ever doing that, I would really prefer it if we were not, if no one was allowed to do that, right? All right. So there's the lighting. It's working just fine. So I think we're good there. So that's all fine. Okay. So I am now building both things, correct? Building the renderer testbed, and I'm building the renderer proper, right? Yeah. Okay. So now we have to start looking at these and crunching them down into something that we actually want, because there's still quite a bit of intermingling here, and the biggest thing that we're going to have to do is the texture management side of things, for sure. The reason that's the biggest thing we're going to have to do is because, for the most part, most of the things that we're doing in the renderer right now are not game specific. Like, we just have textured vertices that you send down and it fills them, right? So it's pretty straightforward, and that would just generalize. Anyone who wants to call that stuff just can. There's just not a lot to it. So the big place that right now we're tightly coupled to the app, and what we're going to spend, pretty much all of next stream doing, we're almost done with this first stream, is texture management, because that's the place where the renderer and the asset system are linked together. And so that needs to be generalized into something that will work both outside of Handmade Hero and inside of Handmade Hero, because we don't want the renderer to care where the textures came from. That's the crucial thing. We don't want that. So that's what we're going to spend the next stream doing. But the first thing we're going to do here is just see what we've got in terms of initialization and getting the render working here. I just want to do a quick spin through this code and see what's going on. So if we pop back over to Win32 Handmade, I want to look at that display buffer and window call. That's this call right here. So what I want to do is replace that with the OpenGL only version. That's this. So it's what calls OpenGL render commands with draw region, window width, window height. I want to know what all of that should look like. So first thing I'm going to do is I'm going to look at what that draw region is. You can see that that's a rectangle 2i. So what I want to do is fill out this rectangle 2i with something sensible. Let me just see what we've got there. So if I want to, I can kind of just use the rect min dim probably to create my rectangle 2i, because what I know is that, well, I've just really all I need to do is just make something that's the right size for my for my window, right? That's really all I need at the moment. So what I'm going to do here is I'm just going to say I've got my I don't know, or display region. Well, you know what? Draw region was fine. Why, don't if it ain't broke, don't fix it. So I want to make a draw region here that I can pass, and I'm going to actually make it so that the draw region is just whatever the. Well, you know what? No. Why even do that? Why not just use the aspect ratio adjust call that we're using before? Like we could do the aspect ratio fit just to make sure we're still blitting properly. We could just do that, right? Because it's a good test. So I'm still going to say aspect ratio fit, and we're going to say width and height here in terms of what the target is, I guess. And then we've got the dimension, width, and height. So what I'm going to say is, look, let's pretend we always want a 16 by 9 window, like so. And then let's say that we've got the dimension, width and height. That's what the window actually has. And I think that'll give us what we want out the back. Don't quote me on that because I don't actually know if it's true. So here I'm going to go ahead and get my window width and my window height and pretend I have those. And then I'm going to call all this stuff. So here's the window width and height. How do I get that? Well, for those of you who remember, I mean, I guess I can just go look it up in here, but you know, it's just get client rect and then you subtract the two. It's not particularly glamorous. You can see it here. Pretty straightforward, right? Oops. Not a lot to it. All right. So our main problem now is just how do I actually know what commands to render for my test? Well, that's now where we start to get into the Snuffleupagus stuff, right? So what we're going to do, and it'll probably take us till tomorrow to get there, what we want to do now is actually have a thing where if we were to allocate these the same way that we're doing it in Win32 Handmade, where we sort of say, look, let's allocate the memory using Win32 allocate or whatever else we're doing. If we go ahead and do that code, then make some things that just clear the screen or something, let's make sure that that works or who knows what, right? So that's all we're really going to start doing here. And then tomorrow, if we get far enough at the end of the stream that we do in 10 minutes from now, well, we're going to take a break and then we're going to do another stream at 2 o'clock. If we get far enough getting everything together, then tomorrow what we'll do is start figuring out what we want for easy API access to it, right? But anyway, so what I want to do here is I want to actually make sure that all the OpenGL stuff, allocation stuff works okay, and start to pull that stuff out into something that makes reasonable sense, right? So let's go ahead and do that. I'm going to go ahead and look at where the render... So here's how we allocated those render commands originally. This is where we did that, right? Is right here. So what I want to do is figure out how to get that going. Here's default render commands, push buffer size, push buffer, width, height, vertex, blah, 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 right? So in order to get that, I need to have this memory, right? This memory's got to come from somewhere, you know? And so that's what I'm going to do here. And I need that Win32 allocate memory call to be available. It's pretty straightforward because we don't need to do any of those things that we're doing there. We can just call virtual alloc ourselves. So in here, what we need to do is just call virtual alloc, as you can see. And so what I can do is just take this basic allocation call, come down here to where this is happening, and we don't really have to do all of this shuffling anymore. I can just say, hey, textured vertex equals this thing. Oops. Still need the cast though. And we don't care about that. So, you know, there's that allocation. Same thing would be true here. Like so. And let's just compile that and get that down into something. Oh, I didn't do this one. There we go. And so now what I'd like to do is I can just call this every time if I want to, right? So I can come down here, and when we do this draw region nonsense, what I can do here is say, oh, all right, let's, make this stuff work that way. This will require our OpenGL stuff to understand a little bit better how large things are. So when you have to when it actually has to go deal with the settings, that's going to kind of be a separate issue that we'll have to look at, right? But the rest of this stuff stays the same and doesn't have to be changed, right? So this stuff is all just totally fine. So let's go ahead and keep going here. Almost to the 5-minute warning. Ooh, that's not what I wanted. I wanted to call like get width on this. So we're gonna have to take a little bit of a look at how that stuff is playing out in a second here. All right, so I just am gonna start with some basic stuff here. I'm going to pop over to Win32 renderer test, and we're going to start stepping through some of this and taking a look at it and how we want it to kind of work here, right? So we're going to enter in here. We process our messages. Don't ask me where that came from. Was this just something left over from... Wait a minute. Where was your... What on earth did it just do? What was that breakpoint? I'm going to go ahead and assume that is a debug build prob. That was a really weird situation. Is that... I didn't like what that was doing. Yeah, okay, that was just a release build. MSVC can't debug release builds. We know this is true. All right, so anyway, this is the draw region of the screen. Here's the size of those. I have to go look to see how we want to spec that stuff out. So that's going to actually be more of a thing later. This all looks fine. I'm not sure how the settings... So the settings have the width and height in there, and this change command actually takes care of that. But the thing that's a little weird about that is why is there another... So why are there two of those? It's a little bit weird, and I want that to not be weird. So we kind of want to deal with that a little bit better than we're dealing with it now. Like, where does that come from, and how does it get retired? So this looks kind of bonkers, and I don't love it. Specifically, what I'm talking about here is forget all that stuff. Forget the render group. That's sort of our separate issue. Just looking at these, the width and height here. Oh, okay. All right. No, never mind. It's fine. I couldn't tell what was going on, why we had two of them. I thought there were two in here. It's not. It just sets it for us. So this does what I wanted. This does exactly what I wanted. Everything's fine. No need to panic. We're good to go. So my next test is just going to be, can I actually do something with my render commands here? So I want to take a look at my render group stuff. Here's the renderer. And so what I want to do is I want to put in like something I can see if it actually works. So let's say I put in a push full clear. Not sure to what extent we still support clearing because it's kind of special purpose now, the way the renderer works, but we will try. I'm going to clear to a nice, wonderful pink color. I'm going to do a begin and end render group here. Like so. I'm going to pass null for the assets because I'm not actually going to ask it to load any assets. And I'm going to pass 0 for the generation ID. Well, we'll pass 1 because who knows. Pixel width and pixel height for the clip rect there. That's just going to be, again, these two, right? And so that should be good to go. And then I should be able to do an end render group as well. Okay. Right. So this is right, I think, where we start to run into the having to extricate things, which is what I said we're going to have to do next. Because now I actually need a way of talking to the renderer. And that requires using this code. And as soon as I do that, now we're bound to the asset system. Right? We instantly run up against the problem where the asset system becomes a necessary component. Since we're right at the end, that's where I'm going to stop. We have successfully pulled everything out into a multi-use thing, and now our goal is to sort of make the texture stuff be something you can use with two different asset systems. Because I'm assuming that the person who's going to use this is using their own asset system, not ours, right? I will do a very brief Q&A, probably only like 10 to 15 minutes. So we will at most use the normal Q&A time because then we're going to all take a break and go get lunch and come back after that. So very brief Q&A here. Are we going to check the recording that ended in an app crash? Yeah, I can. I don't know if it got trashed or not. So that would be this one here. Let's take a look. Yeah, it looks like it worked. Thankfully, I switched to recording FLVs when I set up the new setup, which actually work. I don't do MP4s anymore. MP4s are just gone when you crash, so thankfully the FLVs are there. If we have no questions, we can all go to lunch early and then come back and take a look. But I'll wait just a little bit to make sure there's no questions on what we did so far. Is Vulkan worthwhile for the physical jail? I don't think Vulkan's worthwhile really for anything. But not because it doesn't offer a performance gain. It's because I think you should just use whatever the platform layer is now. So I think what you want to do, if you're going to switch away from OpenGL, switch to D3D or metal, depending on which one you're on. Because I've been over this a couple times. Vulkan doesn't really have a reason to exist anymore, because since Apple is not going to support anything but metal, that means you should write a metal layer on macOS and iOS. That's just what you should do, because you want to be on the main path. They are not supporting anything else. And so that means if you have to do metal, you lost. There's no reason to OpenGL. You don't get a porting benefit anymore. So you might as well do metal on macOS and then D3D on Windows, and that's that. So I don't see any point to Vulkan. It's now a middleman. So if you write to Vulkan, you're actually just writing on top of someone else's API. You should have just written to that API in the first place, right? Because you don't get a porting win anymore. Will we take this opportunity to implement a D3D backend? No, we're never going to implement a D3D backend until the game's done. As long as we have one functioning backend, that's fun. We're done. And then only when we need to actually do like finalized shipping stuff would we implement more backends than just one. Lunch break is till about 1:45. Are there practical solutions to reducing the fill rate in a software renderer? Yes, but I'm not sure. I mean, sure, there's all the same tricks that GPUs use, right? Like early Z out and like storing blocks that have their max Z in them, min-max Z for like early out testing, stuff like that. Testing whole blocks of alpha and then not filling them, all that stuff. Isn't every graphics API just a middleman? No. Metal is actually the lowest level you can write to on macOS. That's what drives the graphics driver. If you use Molten VK, you're writing to an API that then writes to Metal. So you literally just introduced a second thing that can go wrong, a second thing that can slow you down, right? So if you need to access the hardware with something that actually accesses it. Don't write to another thing and then to another thing. At that point, you might as well just be using a higher level engine style thing, right? If it's nuts to think about writing to Vulkan if it doesn't actually talk to the hardware. The only point in implementing Vulkan is to talk to the hardware. If you're going to be going through a middleman, use an API that's better than Vulkan, because Vulkan's a terrible API, right? You'd never use Vulkan to make your life easier. It's a terrible API, right? So the only reason you would have used Vulkan is if it actually lets you talk to the hardware. It doesn't now. Right? It's only on Windows would that be true. On macOS, it talks to Metal, which is now it's just a crappy API you put in between yourself and the actual API you were trying to call. It literally has no point in existing. They should just get rid of it and save everyone the trouble. Right? It's just taking driver team time now. It adds value for nobody. If you want Vulkan to have some reason to exist, then just give the whole Vulkan concept and project over to the Android Linux people, because they're the only people now who could really do anything with it. It's the only place it would actually have any use would be for them, because they don't have their own graphics API, right? So maybe as a replacement for OpenGL or something, I don't know. Other than that, on actual consumer game platforms, it doesn't really have any point in being there. How do you recommend a beginner get better at writing platform layers? Is the only way to just write a bunch of them to figure out how the common patterns work? Yeah, more or less. You just got to practice at it. Understand, sort of the stuff we've been saying about where you put boundaries. You want to watch people who know how to do it, and think about it. But Ronan says, I'm one of the Linux people. Please don't give us Vulkan. Yeah, I'm sorry. I didn't mean to wish it upon you. Um, but I don't know. Linux doesn't have another graphics API, really. It doesn't have its own low-level graphics API, does it? I mean, it's got sort of the Wayland stuff, but that's not... I thought that was just for window compositing. Like I didn't think that was like a full 3D thing. So there isn't like the equivalent of... There's like D3D12, there's Metal, and then there's like Linux and Android. I don't know what they've got. I don't know what's the native thing on Linux, really. I think largely because Linux doesn't care. Like, Linux is a compute server platform, It's not really a consumer platform, so it's not the kind of question you ask, I would guess. For them, probably the important things are like OpenCL or something. All right. That looks like we don't really have any questions on the code reorganization, so I think what we will do is just close it down for now, and I will be back at 2 to do the second stream of the day. Hope to see you back here for that. In the meantime, go have some lunch or whatever the appropriate meal is for your time zone.